So when we talked about polynomials and we talked about their graphs, we talked about them being smooth and continuous. They sort of went on forever. And so when we think about an important characteristic of polynomials, what we want to talk about is their end behavior. So what's happening as the values of x get very large and very large in the negative direction, okay? So we can write this as x goes to infinity or x goes to negative infinity. So the behavior of the graph as the input values get very small, x going to negative infinity, and very large is referred to as the end behavior. So we write as x goes to infinity, which is on the right-hand side. If you're thinking about a graph, infinity is kind of over here on the right, and negative infinity is over on the left. If the graph is going up like this, we'd say it's rising, or y goes to infinity. If the graph is going down, we say it falls, or y goes to negative infinity. Then we can do the same thing for the left. If it's up here, it's rising, y is going to infinity. If it's down there, it's falling, y goes to negative infinity. And remember that y is just a representation of f of x, the outputs of the function. So we want to try to determine the end behavior from a graph and also from an equation. So here's how we start, and we say, given the following graphs, determine if the degree is even or odd, if the leading coefficient is positive or negative, and then determine the end behavior. So let's think about what happens here. When you think about the graph of x squared, you should think about a parabola like this. And notice that the two ends are both going in the same direction. Whereas when you think about the graph of x, a line, one end is going up while the other end is going down, okay? So when the degree is even, the ends behave the same. They either both go up or both go down. When the degree is odd, the ends do the opposite, one up, one down. So both rise, both fall, or one rise, one fall. The way you can determine whether they're going to do the rising or falling on the right-hand side is by using the leading coefficient. So the leading coefficient if it's positive, the right-hand side rises. If it's negative, the right-hand side falls. Because when you think about x squared, remember if we wrote negative x squared, the graph would be turned upside down like this, and both ends would be falling, and that has a negative coefficient in the front. So a degree tells you whether the two ends behave the same or opposite, and the leading coefficient, if it's positive, it's going to rise. If it's negative, it's going to fall. So in this first picture, we see that one end is going up and the other end is going down. That means that the two ends are doing the opposite thing, so the degree has to be an odd number. Since the right-hand side is going up, the leading coefficient has to be positive. If we're going to use the notation, as x goes to infinity, it's rising, so it goes to infinity. We're over here. As x goes to negative infinity, remember infinity's here, negative infinity is here, it's falling, so it's going to negative infinity. If we look at this second example, I notice that the two ends are both going in the same direction. That means that the degree is odd. Because this right-hand side is going down, the leading coefficient is going to be negative. What I notice about these two ends is that it's falling on both sides. It's falling on the right, falling on the left. So on both sides, the y values are going towards negative infinity. So that's how we can do it from the graph. What if we just have an equation? How are we going to do it from there? Well, we're going to use that leading term. So remember, the leading term is the one with the highest exponent. So in this function, the leading term is going to be 3x to the fifth. That means the degree is 5 and the leading coefficient is 3. Since the degree is odd, one end is going to rise and one fall. One rise, one fall.
Remind.
Since the leading coefficient is positive,
Remind.
the right-hand side is going to rise. So the right-hand side near infinity is going to go up to infinity. We know that the degree is odd, so the left-hand side is going to go down. Okay, let's do the next one. We're going to look for the leading coefficient. Again, it's that first term there, negative 5x to the third. So the degree is 3 and the leading coefficient is 5. So that means because this degree is odd, they're going to do the opposite, one rise, one fall. Because this leading term is negative, the right-hand side is going to fall. So the right-hand side, this one, is going to fall. They have to do the opposite, so the left-hand side is going to rise. Okay, last example, we're going to look for that leading term. It's negative 6x to the 8th. The degree is 8. The leading coefficient is negative 6. The degree is even, so they're either going to both rise or both fall. Because the leading coefficient is negative, the right-hand side is going to fall, which means they both have to fall. So both terms, both ends are going to go towards negative infinity. If you're thinking about these in terms of a graph, this one's going to go up on that side and down on that side. This one on the second example is going to go down on the right, up on the left. This third example should be going down on the right and down on the left.